Okay. So come to the fourth session. This session we will look into logistic regression and regression tree analysis. I hope you can see the slide. Let me know if you can't see the slide. Yeah. Okay. Let's start. Okay. So last week we discussed about regression. Okay. And this week we will look into logistic regression and also um, regression tree. Um, yeah, last week we discussed about simple linear regression, also multiple linear regression. So the difference between simple linear regression and logistic regression is that for a simple linear regression, we use that one to model dependent variable which is numerical value or continuous value. So for example, we are looking at the stock market, or we are looking at um, the yield production, or we are looking at the company profit over time. So this one we try to focus numerical value or continuous value. In comparison to logistic regression, we are looking at categorical value for the dependent variable. So meaning that if you have your independent variable and we use this independent model your dependent dependent variable in which your dependent variable is categorical value or nominal value or uh, ordinal value. Okay, so for example, like this, we are looking at y. Y, this is your dependent variable. Okay, and we are looking at your independent variable. What is the probability of having this one? So this classification problem is best modeled with the probability that are bound between 0 and 1. So, for example, male and female, they are nominal value. Purchase versus does not purchase, they are nominal value. And tumor is benign or malignant. These are categorical value. So for the logistic regression, a special case of regression analysis that is calculated when your dependent variable is nominally or ordinally scaled. So for example, female, male, not bi or bi, and so on. So what we do is we look at the probability of having male or female. So for example, like this, this is your dependent variable. We use all of these independent variable to say what is the probability of having that disease. So we are looking at the probability of occurrence of characteristic 1, which is do we have the disease or not? Yes or no? So when we try to understand the logistic regression based on linear regression that we have, So this is what we have learned before. Your dependent variable is y. This is your dependent variable. And this is your independent variable. So we are looking at, okay, this is your x. Your x1, x2, x3, and so on may occur at this point, all here. The y here fall between 0 and 1. So either they have, either they do not have that value, um, either the probability is 0 or 1. So the goal of logistic regression is to estimate the probability of occurrence. So the value must be within 0 and 1. To ensure that only value between 0 and 1, we will use this logistic function. If we look at the logistic function, so the value for the y will always be from 0 to 1. Okay, so starting from negative value up to positive. Okay, so this is the logistic function that we have. Then the z here will be represented by the formula of the linear regression here. So notice that given x1, x2, x3, and so on, the value for this y hat will be 0 or 1. So if the value of hat y is 0, so what happens if we have this? So we will have 1 plus and then 1. So this is what? Half, right? Okay. So what happens if we have value for this 1? So we will have 1 plus. So we will have e minus 1. But e minus 1 is actually what? 1 over e. So if this is going to maximum, so the whole value will be 0. So when this formula is 0, so you will have 1. So the value will be from 0 to 1. Okay, depending on the value of this one. So what we need is to use the logistic function in order to have this situation. We are looking at the probability of occurrence of that particular dependent variable from 0 to 1. Okay, so any question? No? So any question? So let's look at one example. Before that, we will look at the processes involved in classification. I think we have covered this one previously. But the first thing that we need to do is we need to do data preparation, which involve data cleaning or handling missing value. And then we will train the model based on the training and testing data. And we'll use the testing data to evaluate the predictive ability of the model. Okay? So in this example, this is the actual data that we have. So we will go through how do we perform data cleaning, how do we look at the values, and then how do we handling missing values and so on. So remember this step. So the data set that we'll be using will be train. So this is the famous Titanic event in which they try to predict whether someone is can survive based on the class of the train, like first class, second class, and so on. Then the sex, and then the age, how many number of siblings. This is the parent, ticket, fare, and cabin. Okay, and where they join the ship. So this is the dependent variable survive. So we want to predict whether someone can survive, cannot survive based on some of the parameter that we have, the independent variable. Okay? So the value is 0 or 1. If you survive, 1. If you are not survive, then 0. So in this scenario, we can use logistic regression because the value is between 0 and 1. Okay? Okay, so this is the description of the data. So this is your dependent variable. Okay, and the P class refer to the ticket class, sex refer to the gender, age refer to the age. This one will be number of siblings, spouses aboard the Titanic, number of parents, children, ticket number, passenger fare, and so on, cabin number. And this is where they join the ship. Okay, so in the data cleaning, what we want to look is, are there any missing values for some of the cells? So what we do, we looking at this for each of the column that we have. We look at whether that particular column have an A. An A refer to missing value or non-applicable. So if you look at here, we have this cabin, most of them empty, and this one and this one. And we also look at the number of unique value that we have in each of the column. So we can use this length and then unique. So this will give us the number. So what we want to do is we want to clean up this one because this is an A or applicable value for some of the cell that we have. So how do we clean that one? Okay, since this one we only have 2, so what we can do is we can remove that particular row. And for this one, since we have too many of them, so maybe we can remove this cabin from the selection of the independent variable that we have. And this one, maybe we could use the average age. Okay, so how do we do that? We could visualize the number of cell or the number of record that has missing value. So we can use this mismap. Okay? So missing value will be 8% from all the data that we have. Then the blue one missing. Okay? Cabin, many missing values. So we could omit that one from our analysis. So what do we do? Okay, we remove this because this has nothing to do with the probability of survival or not survival. Okay, we also remove the name because the name has nothing to do with um, survival of the person. We remove this because so many missing values, and the ticket also because this ticket is just referring to the ticket that you have on your hand. So we are looking at the where you sit in the train or in the cabin. What is your gender? What is your age? How many siblings you have? How many parents you have? And then um, where do you the no where you join the ship? And then this is the fare. So the fare highly depends on class, the class of the cabin that you sit. So we will select only this column. Okay, how do we know that this is 2, 3? So we will be able to look at from here. So this 1 and then 2 and then 3 and so on. So we could select only some of them and omit the other things. Okay. So we the subset of this column we put in data, and for all the data which is missing in the age, okay, you can check just saying that for all the data that we have in the age which is not applicable, I will assign them the value for the mean age, okay, not including the not applicable, meaning that I'm getting the mean age only those exist. So I'm not looking at the total number of rows that include a missing value. So this one will take the mean average to replace all the NA value. And we also double check whether the gender or sex or this one embark factor or label or not. Factor is they are ordinal or nominal values. Okay, we also look at the sex here and also the embark here. So we can use this contrast function to look at the categorical value or variables that we have. Okay, since for the embark column we only have 2 rows, so we will eliminate them from the data. So which means that a new data will get a data which exclude all the row that contain not applicable for this column. And the row names data means I will delete all the row names because when you created the data frame for data, they have a hidden row name 1, 2, 3, 4, 5. So I will remove that one. So we have dealt with missing value for the embark and then the age and also the cabin. Okay. Now we look at how do we split the data. So we could split the data using this command. So this is referring to row 1 up to 800. And then the second one here, we didn't mention anything, meaning that we include all the column. Okay, so the testing also we start from the 801 to 889. So this number up to you. You could have 50-50 or 70-30%. Okay. So once we split the data, then we could use the logistic modeling (GLM). Okay, so we want to model the survive column based on all the column that we have in the data that we have. So the dot here referring to all the column that we have in the dataset. So we are using binomial because the binomial the range of output will be from 0 to 1. So that's why we use binomial function. Okay, so once we perform the logistic regression analysis for the training data, so we could check the summary. The summary will tell you which column are significant in describing the survive dependent variable. So we know that the class you in, and then your gender, and then the age, these three are significant in determining the survival of the person. So the 3 star here referring to 0. Normally we use the p-value to be 0.05. If we have smaller than that, it's even better. Okay, so this when we perform the training, but how do we know? How do we assess the performance of the logistic regression? What we do, okay, the result that we get from this model. Okay, so all the results will be stored in the model. So what happens is that we use the model to predict test data set that we have, but we only include this one, not including the survival. Okay. So we have one here, but we remove them. So we only take 2, 3, 4, 5, 6, 7, and 8. Because we look at the test data set. Okay, the test data set will have get the test data set from the data, but the data coming from here. Okay, so 2, 3, 5, 6, 7, 8, and 12. So all this will be transformed to 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so all this will be assigned to your data here. So the first one is the survival. So we will omit that one because that is Yusra. Okay. So when we call the prediction, so we are looking at 2, 3, 4, 5, 6, 7, and 8 only. One is the column 1 is the dependent variable, so we will omit that one. So this variable will store the result. Result will be in terms of row and then 0, 1, 0 or 1. So we'll change them into 0 and 1. So if the result is greater than 0.0, 0.5, we change to 1. Okay, so less than 0.5, we change to 0. So the fitted result here will be value 0 and 1, 0 or 1. So okay, to compute the error, we will get the result here. Then we look at the number of rows that not equal to the actual survival data that we have. Okay, so we compare equal here. So we will collect all this value. Then we put in the misclassification error. So your accuracy will be 1 minus whatever error you have. Then you get this. Okay? So that means your logistic regression will have 84% accuracy. Okay? So that's how we use the logistic regression to predict the probability of occurrence of the numerical value that we have. So in this example, we are looking at the survive and not survive. So if we move on to the next one, so the next one is regression tree. So this is a bit different from linear regression and also logistic regression. It is used to look at the numerical value as the dependent variable. So this regression tree do not use linear regression method. Rather, they make prediction based on the average value of example. So we are looking at this one, average value. Okay. For example, this is the example when we do the wine testing. The wine testing give you scale between 1 to 10. So if you like the wine, you put 6, 7, and so on. So what they want to do is they want to know why people put 6 or 7 or 8 for the rank of the wine based on the content of the alcohol. So they want to study this one. So that means your dependent variable will be a scale from 1 to 10. And then this is predicted by using all the dependent variable, which is numerical. So notice that this is scale. This is numerical value. If you compare with logistic regression is looking at the probability of occurrence of having that particular item based on dependent variable. So for the regression tree, we are looking at the average value. So for the numeric decision tree, homogeneity can be measured by statistics such as variance, standard deviation, and absolute deviation from the mean. So all this can compute this based on the average or mean. So we can derive the variance, the standard deviation based on the average and means. Okay. So the formula that used by the regression tree is we want to reduce the standard deviation. Okay. So if we have small standard deviation, it means all the value fall under a very similar value. For example, if we have x here, okay, if our mean is here, this is our mean. But if your standard deviation is too big, this is standard deviation. So which means that all the value fall away from x. But if your standard deviation is very small, for example, this is your y, and your standard deviation is here, which means that most of your value fall almost near to the mean. So we want to split the value so that we can reduce the standard deviation that we have. Because we're looking at the trees, huh? So when we split them into two, which means that okay, this is your attribute salary. Okay, so this is greater than 50k. This is less than or equal to 50k. So we want to find the right value for this that will split them into two, that will reduce the standard deviation the most. Let me give you the example for this. For example, like this, we have the original data, is this one. We have the choice to split the data into two because for feature A, we can split them into this is less than 6. This is greater than or equal to 6. Okay? And for the B, we could split the data to T1 and T2. So this is less than 5, less than 5, and this is greater or equal to. Remember that we want to split. We use the attribute split the data in order to estimate this one. This is your dependent variable. So similar to this, which feature A or B could reduce your standard deviation? So we could use this formula. So this formula is basically looking at standard deviation of that particular partition, and this is the weightage for that particular partition, and we will do it for all the partition that we have. Since in this example we only have two partitions, so this is how we can compute them. So this is your original data, and this is the feature split using feature A, and this is for feature B. So we can compute this one. So we are saying that the standard deviation of the original tree or partition minus minus two partition. Yeah. So this is the first partition, and this is the second partition. Okay. So first partition, and then this is the second partition. And this is for the B. So if you look at the standard deviation reduction, this is bigger because we want to maximize the standard deviation reduction. So we choose B. So splitting your data into two using feature B is better because we have maximized the standard deviation reduction. This is just the example. So basically in the real situation, you need to test for one and then this. Wait. Need to test for when we split the data here. then the data here again, here, here, and here, and here. So we need to test 1, 2, 3, 4, 5, 6. 6 partition that is possible for this original data. But in this example, we only did 2. So in the actual process, we need to for all 6. So let's take a look at the example that we have. Suppose we have this data. So we have almost 5,000 wine samples, and for each of the wine sample, we have 11 chemical properties. So in the wine testing, the judge will give a scale ranging from 0 if the taste of the wine very bad, or 10 if excellent. So this is very subjective because different people have different taste or perception and so on. But we could model this because our scale is from 0 to 10, and our independent variable, we have 11 features. So how do we perform this? So first, we will read the data from this. Then we look at the structure of the data frame. So we have all these 11 features, and this is the dependent variable that we looking at. So we want to model this based on all the 11 features that we have. Okay, and if you look at the distribution of the wine quality, so most of them put in 6 here, and only a few put here. So over here meaning that the wine tastes bad, and over here that wine tastes good or excellent. So once again, we'll divide the data into training and testing. Okay, the training data will be used to train the model. So this is just to install the regression tree that we have. Install and upload. So how do we model them? So we use this regression tree to model this quality based on your independent variable. All the independent variable, we just put dot. So if you want to analyze based on subset of the independent variable, you can set each features, and then you can plus for additional features that you have. So we will use the N here, the training dataset. So what we have is this one. This one is very confusing, but what we can do is we can install this package, the regression tree plot, and if we type this one, then we can have this one. So how do we read this one? Okay, so meaning that if we split the alcohol at this value, okay, so if the alcohol is less than 10.9, and we look at the acidity of the wine, so if they are greater than 0.228, then we go here, and again if the acidity is greater than 0.302, then we go here. So that means people will put a vote on average this one if fulfill the value of this. So this is like a rule. But if you want to go here, meaning that the content of the alcohol must be greater than 10.9, and then the sulfur dioxide must be going here will be less. So going here will be more. So the sulfur dioxide must be more than 10.5, and then the alcohol again must be greater than 11.8. So that's how we use the independent variable to determine how people judge the taste of the wine. So this is very interesting because you can do any analysis for this using this regression tree, but we have to know what type of data that you have. And of course, it's good when you have the dependent variable and then your independent variable. So this is all the numerical value, and this is numerical value also. Okay. This is another way on how you can plot. These two are the same. They're using different command. So up to you which one you want to. So how do we evaluate them? So this is the model that we have is here. This is the model that we have created when we call this function regression tree. Okay, so we will use that particular model to perform the prediction using the data that we have. So we will perform the prediction here. So this is the prediction result that we get. So this is the summary for the prediction result. Then okay, so what we want to do is we want to compare this with this. So this is the original value. So this is the predicted value. So since they are both numbers, so we could use the correlation to look at how close they are correlated to each other. So based on this, I say that the predicted value has 0.53 correlation value with the quality of the wine. So the higher is the correlation here, the better is your modeling. So you need to understand why do we use correlation, because the output that we get from the prediction will be numbers. Okay. Remember this value. This is the prediction that we get. Then we will compare with the actual quality. So how do we compare? So we use the correlation. Okay. We could also use the mean square error. How much error we get between the actual and also the predicted value. But using correlation is also good because it tells you how close they are related to each other. So there'll be practical assignment for this one. These two are very short. They are very useful when you have the right data set or the right problem that you want to analyze. The most common method used is the simple linear regression and multiple linear regression. But now you have studied this logistic regression and also regression tree, and you should be able to differentiate between simple linear regression, multiple linear regression, logistic regression, and also regression tree. That's all you need to be know for these two last lecture. You need to be able to differentiate, and then in future you should be able to determine which method you want to use to perform regression analysis, simple linear or logistic regression or decision tree. So any question?